Okay, so we're going to be looking at an optimization problem similar to the one we did in today's notes. Okay, the difference, we're dealing with a rectangular prism, but in the notes it was basically a complete box. In this one, we're actually going to be an open top. So I want to make a fish tank with a volume of 2 cubic meters, and I would like the base of the tank to be a rectangle twice as long as it is wide. The base and the sides of the tank are to be made of glass, so all the sides are made of glass. What shape of the tank will use the least amount of glass and so cost the least? Okay, so again, I always tell my students the first thing you should do is basically draw a picture. Draw a picture of what this is going to look like. Okay, so let's see. There we go. Oh, I want to grab that. Move that there. Duplicate it. Okay, so basically we have looks something like this. Connect these. Okay. All right, so here's my tank. Now, all of the sides are going to be used, but it's open top. So it says my length. Okay, so let's say this is the width, this is the length, this is the height. So my length is twice as long as it is wide. So let's say the width is say x, the length is then 2x. Okay, so we're trying to find our primary and our secondary equations. Okay, so what is my primary task? What am I trying to optimize? I'm trying to use the least amount of glass. So the materials. So the materials in this case is the tank itself. That is the surface area. So we need to write an equation for the surface area of this tank. So the surface area is going to be equal to, now remember, this top part here we're not going to have any glass. So we got two sides, the front and the back, which is 2 times W times H, plus the two sides on either side, which is 2 times length times H, plus the bottom, which is length times the width. Okay? So that's my surface area equation. Now, what am I trying to do? Well, what's my secondary equation? What are my limiting factors? Well, the volume has to be 2 cubic meters. So my volume is my secondary equation. That's what's limiting everything. So over here, volume of my tank is of course length times width times height. Okay? So now my surface area equation is, we're going to simplify it by using the x and the 2x. So wherever you see w, I'm going to put x. So this is 2xh plus 4xh plus 2x squared. Okay? When we simplify, and we get 6xh plus 2x squared. So that's my surface area equation. But again, I've got this h in there. Okay? I've got to get rid of it. So what I'm going to do is I'm going to use my volume equation to solve for h. So I'm going to do the same thing for volume. I'm going to replace length and width with my x's. So that's going to give me 2x times x times h. Volume equals 2x squared h. Okay? And then I'm going to use my qualifier. So they told me the volume has to be 2 cubic meters. So 2 equals 2x squared plus h, which means when I solve for my height, I'm going to get 1 over x squared. So that's what I'm going to use to plug into my surface area equation. So this h right here, I'm going to plug it in for this h here. And that will get my primary equation all in terms of one variable. So I get my surface area equals, this is going to be 6 over x plus 2x squared. Okay? So when I plug in my h and reduce, because it's going to be 6x times 1 over x squared, and then the x's divide out, so you get 6 over x. So now I got to find the derivative. So surface area prime. The derivative of 6 over x is negative 6 over x squared plus the derivative of 2x squared, which is 4x. Then we set it equal to 0. Solve for x. So be smart about it. I'm going to move my negative 6 divided by x squared to the other side. So I'm going to get 4x equals 6 over x squared. Cross multiply. I'm going to get 6 equals 4x cubed, which means x cubed equals 3 halves by dividing both sides by 4, which means my x value is equal to the cube root of 3 halves, which if you plug into a calculator is approximately 1.1447 something something something. Okay? So I don't even have another value to test. I have one value. Now they need the shape of the tank, so my x value, that is my width. I just found my width, so this is my width. So my width equals the cube root of 3 over 2, which is, like I said, 1.1447. My length, which is twice my width, is 2 times the cube root of 3 halves, which is approximately 2.289428. And of course my height, which is right here, is 1 over x squared, which is 1 over the cube root of 3 halves squared, which is, approximately 0.763148. And those are my dimensions right there. Okay, so remember, you cannot stop. Once you find an x, you can't stop. You have to make sure that you find what they're asking you to find. In this case, it specifically asks us to find the dimensions. Okay, so what is the shape of the tank? That's the shape. Length, width, and height. Okay, now I always have my students tell me how difficult calculus is, but I just want to point out something to you. This entire optimization problem, all of it that we did, the only calculus in this entire problem is right here. When we took the derivative, that was the only calculus. The only calculus that you learned this year. The rest is algebra and a little bit of geometry. Okay? So when my students tell me how difficult calculus is, what they're really saying is that they're experiencing trouble in the algebra, and that's the #1 problem that we see on the AP exam. So for those of you guys that are struggling, it might not be the calculus. You might be struggling with the algebra.